So our next core walkthrough will be through the Pecos D Fee 2. This core has two intervals, one down in the siliciclastic dominated interval and one up into the carbonate dominated interval. So the Pecos D Fee is in the middle of that little cluster of well we are looking at in this study. It's the core highlighted by the blue box on that core cross section. As I say, has a bottom part that is siliciclastic dominated below that green line, which is top of the wall, can't see, and has a top part it is carbonate dominated, highlighted by those two blue lines on the cross section. Here's the well log curve on the left here, again gamma ray with the color bar from 0 to 150, and the red curve is the sonic. And on the right we have the Ian coarse decryption for both intervals that were cored. We can see that the bottom part has a high gamma ray but slightly lower resistivity, which match the lithology that Ian described in the core, which is mostly siliciclastic mudstone and sandstone alternation. And then in the upper part we see a little bit lower gamma ray, slightly higher resistivity, more blocky, that match the carbonate lithology and debris flow that are in the upper part of that core. So we'll focus first on the lower part that is siliciclastic dominated. So if we focus on that lower interval, we can see that we have two gamma ray peak and two faster zone in the sonic. On Ian core description, we can see we start with siliciclastic mudstone, then we have a 25 feet interval dominated by sandstone, breaking core, some more muddy facies, then a second interval capped by siliciclastic sandstone, and maybe like a little carbonate bed in the middle that's really prominent on the XRF calcium curve there. In terms of clay content, the siliciclastic part has about 20-25% clay in the siliciclastic mud, and then mostly clay pore and all the sandy and carbonate facies above it. In terms of TOC, again, the siliciclastic mudstone have 1.5 to 2.5% of TOC. In elemental distribution, it's mostly dominated by silica and aluminum, up to 30% silica, only 2 peak of magnesium and calcite. That seems to be limited to this two bed in the upper part of the core. This is a montage of all the core box photograph labeled Ian classification of facies. Just by color we can see that we have a dark interval at the base that is this laminated siliceous mudstone, and then we have intercalated between darker bed, lighter, more massive bed. Those are the sandstone turbidite, pretty thick interval in the middle of the core here. Then we get some little muddy interval, two big core gap there, more muddy interval with some thin layers of lighter colors, which are most probably sandy, thin sandy turbidite. Then a tan bed that's highlighted by the blue color here, that's going to be one of our carbonate bed, and then back to more massive turbidite at the top. So we'll walk through this core in the next 10 minutes or so. The first 10 feet of the Pecos D Fee core is mostly siliciclastic mudstone with some gray interval that are centimeter to 3 centimeter thick. Here the close-up photo show you that those are medium to coarse grain laminated quartz sandstone turbidites. Some are maybe slightly ripple. The siliciclastic mudstone have actually a fair amount of sealed sides quartz grain in it. They also, like this thin section show, are laminated, which is not very easy to see on the core itself. Here's an example of several of those millimeter scale, very dilute turbidite, partly made of very fine grained quartz sand. Above this, we got 2.5 foot of siliciclastic mudstone, and we get the first one of this whitish bed. This is about 20 centimeters of this medium to coarse grained sandstone. It's a pretty short top, the base is hard to see, and we interpret that as a pretty high concentrated turbidite. Then we have more mudstone, and then another 5 centimeter thick interval of laminated medium to fine grained sandstone with dark laminae on top of each flow. These flows look to be normally graded, and this is a stack of maybe 4 flows of those dilute turbidite. Then we get a little bit of mudstone, and we hit the next package, which consists of 2.5 feet of clean structureless white sandstone. You can see the enlargement here on the left. There's a little bit of oxidized clast in this sandstone. The thin section here on the right shows that it's a medium grain, pretty angular grain sandstone, and then the top, at least the top of the core, has a little bit more of the coarser grain material with a lot more of those clasts in the sandstone. We interpret this again as a high concentration turbidite. So here's the core description from Ian again, from the base of the Pecos D Fee. So we went through that muddy interval at the base that has about 30% clay content in it, TOC up to about 2, and then we reached this couple of sandstone bed before the break that were pretty clean. Clay content came down to a few percent, and so did TOC. After the core break, we got about a little bit over 12 feet of white medium grain sandstone with no obvious break in there. There might be a stack of amalgamated turbidite. Hard to see, the core is not in great shape here. If we look at the enlargement here, we can see faint lamination and a dark clast here that are part of the organic matter or plant remain in this high concentration turbidite. The top of that package is made of successive 2 to 3 centimeters rippled medium grain sandstone that are interpreted as less concentrated turbidite. They might be a bit finer grained than the massive bed below. Just above this, there's another 3 feet clean sandstone bed. Here's a close-up view. It is laminated. All this little reddish hue to it, which is probably due to siderite. On thin section, we can see it's another medium grained sandstone. We can see the laminates. Here's an example of the mud clasts that are inside this sandstone. And this last thin section show you a detail of the cement in between the quartz grain, which is actually siderite cement. This interval of massive sandy turbidite, high concentration turbidite, is capped by about 10 feet with the core gap of siliciclastic mudstone with centimeter to 5 centimeter thick, more dilute turbidite. In the example here, we see some flame structure at the base. Both these flows here seems to be somewhat graded with more muddy fine grains laminated intercalation. The other flow here on the left are even thinner, millimeter scale here, maybe very fine ripples or discontinuous lengths of partly sealed to fine grained sand quartz in those lamines. Above that muddy interval, we got our first gray fine grained bed with maybe some carbonate in it, and then a 25 centimeter tan yellowish bed that if you zoom in shows there's a very coarse grained rutstone type texture made of carbonate grain that are completely silicified. On the core description, you can see that bed here, coarse grain. You can see in the XRF has quite a bit of carbonate and magnesium in it, and low aluminium and silica, very low TOC2. On fin section, we can see that it's mostly made of small fuses, crinoid fragment, other skeletal fragment with some cement in between. If we look under fluorescent light, we can see that all these carbonate class have quite a fair amount of microporosity in it. There's just a little bit of intra-cement porosity too. Under cross polarization, we can see that this rutstone bed is totally certified, silicified. And then just above that rutstone, there's a few centimeters of siliciclastic mudstone and a rusty tan bed of fine grain to medium grain sandstone. Then some more siliciclastic mudstone with thinner turbidite in it, and then the rest of the core is dominated for the last 7 feet of this stack of sandstone bed. The base of the first sandy turbidite, which is about 6 feet thick, has some interesting sedimentary structure there. As you can see on this close-up, we got those truncated climbing ripple and this little mud layer in between. Those are kind of typical of those supercritical flow with the flow surge and winding. So this is a kind of a neat feature of turbiditic current here. Above the ripple base, then we go into more massive sand, and then horizontally stratified laminated sandstone, and then toward the top we get some erosion surface, inclined laminae, showing maybe the winding flow, little mini ripple on top before the mud gap, and the next coarse flow is coming above it. So again, above it, that tan bed has a weird base, maybe has some rip-up mud class, the flow that grab at the bottom, and then we see this crude stratification, horizontal stratification in it, with some pretty big class in a fine to medium grain sandstone. And on fin section we can see that those class are actually carbonate class, mostly crinoid and pieces of fusillinate laminated into that sandstone. Above this sandstone with carbonate fragment in it, we have a interval with those thin centimeter scale sandy turbidite with all sorts of ripples in it, and then become more massive and thick. They are laminated with commonly the top is ripples and truncation surface. And then above that, more horizontally stratified sandstone with ripples on top, a little thin mud cap until the break in the core. So to summarize, that core interval has a muddy base with thin diluted turbidite, then a big stack of massive to laminated sandstone, back to more muddy interval, break in the core. We got a couple of little beds. One is a carbonate rutstone, and then we have some turbidite with carbonate fragments in it, and then another stack of laminated to rippled turbidite with some great example of rippled laminae, truncated climbing ripple, all this evidence for surge flow and supercritical flows of sandstone into the basin. And if we go back to the well log curve, we can see that these different stack of massive turbidite probably correspond to those two gamma ray peak in in the well log, so that well curve needs to be shifted compared to the core.